Welcome to Make Made Simple. Today we will be studying what is the friction force, its graphical representation. So I have made a graph here in which the x-axis is the applied force and the y-axis is the frictional force. So this is the applied force on the block M, which is kept on a ground, and this is the frictional force. So what all forces are acting on this block are mg, its weights in downward direction, and a reaction force n, which is pointing towards upwards, and which is equal to the weight of the object, that is mg. So when we are pulling on this object in this direction, as we are pulling, this force increases along the x-axis. This force increases along the x-axis, and the frictional force will be in will equal the applied force. The frictional force will equal the applied force. Like if it is say 1 Newton, then frictional force will be 1 Newton. If this is 2 Newton, then this will be 2 Newton. So like that, the frictional force will go on increasing till the frictional force max is achieved. That here is the frictional force maximum. So at frictional force maximum, the frictional force will drop down and then go in a straight line as this. So when we are increasing friction force in the kinetic case, the frictional force remains constant, and which is equals to friction force mg nu k. So we have two types of friction: static friction coefficient and kinetic friction coefficient. Static friction coefficient and kinetic friction coefficient. So those are the two coefficients, and the f net from this graph, if we calculate what is the f net, then it will be equal to f minus fr, that is the friction force. It will be equal to 0 when f is shorter than fr max. When f this f is shorter than fr max, that is we are in this portion, then the f net will be 0. That is, the slope of this graph is 1. The slope equals 1. So that's the case with the graph here. And when we are in the kinetic phase, when the body is moving, when the force is applied and the body is moving, then in that case the net frictional force is equal to F minus FRK. K stands for kinetic. This is kinetic. Then when F is greater than FR max, applied force is greater than FR max. In this case the object is moving. So that's the case when we are to recap what this lecture had all said, was that when we are applying a force on an object, then the applied force goes on increasing, and also the friction force goes on increasing, and they are both equal until FR max is achieved. After FR max, the graph decreases and we get a force which is constant and which is equals to mg nu. So in static case, the friction force is mg nu k, and in the kinetic case, the friction force is mg nu k. Nu k in the kinetic case and new s in the static case. So that was all for today. If you enjoyed this video, please do like the video, subscribe to my channel and share it among your friends. Thank you. Let's meet in the next video.